to East Windsor Lincoln Technical Institute. Myself, Mr. Nowak, and my cohort, Mr. Morozov, who's behind the camera, are here to give you guys a little bit of a training on our solar trainer. I want to make sure that you guys understand the parts and get to physically see them, even though you can't be here in the school. So this is for ET 122A and 123A photovoltaics 1 and 2. All right. So let's start off with the first part, the watt-hour meter. This is where the electricity is charged, right? We got to remember that watt-hours is money. As far as the utility company is concerned, this is their money, and they want to know exactly how much you owe them or how much they have to give you back. So the watt-hour meter first. It's connected to the utility that would be connected here through this cord into the AC circuit that is at the building. Now, it goes into disconnect. Disconnect is our main service, right? Disconnect here inside, fused, has white, black, and red, although the red is identified with tape, to show the single phase 120, 240 volts that is going to head into the rest of the system. Our next part here is the solar charge controller, and this is the in-between of the solar panels, which are on the back, we'll show in a little while, and the connection to the batteries, which are located down here underneath the table in this drawer. We'll show later. So the solar charge controller is outdoor equipment that is designed to basically control the DC circuit and control how much charge it puts to the batteries. This is our power distribution panel. This would be like the main panel in your house, all right? We're gonna open this up in a little while and I'll show you the interior of it, but right now you can see 3 breakers up here that are for the AC circuitry, and then 3 breakers down here that are for the DC circuitry. All right, so the power is gonna come in from the solar panels and it's gonna go through this breaker before it hits the charge controller. Then from the charge controller, it's gonna come back here and hit this before it heads to the batteries. And the batteries are going to be disconnected from this to the inverter, which is located right next to the distribution panel. The inverter here is going to be our power from the DC. So the solar and the batteries are going to be inverted to give us power for the AC loads. This here to the side is the system control panel. This is connected to the inverter and to the charge controller, and can keep tabs on both of the pieces of equipment at the same time. This here is the combiner box, which is used to basically take the wires from our solar panels. So this is one set of solar panels. This is the other set of solar panels. And they come in here to the combiner box. And through the breakers here, we can disconnect or connect them to the rest of the system. This is the load center, the AC load center, the panel in your house, so to speak. So you have your circuit breaker panel in your house that you get your loads for your 120 volt loads or your 2-pole 240 volt loads. And these loads are what are being fed from the inverter and fed from the battery. Now on the back side here of our trainer, we have our solar modules, our PV modules. So we have 2 modules connected in series with each other and another 2 modules connected in series with each other, and these two are connected in parallel with each other through the combiner box. So one set of 2 wires are these 2 in series heading to the combiner box, and the other set of 2 wires are these 2 in series heading to the combiner box. Now, I'd like to go back over to the combiner box and show you one thing that's code related that should have been taken care of a while ago, but it's good that we can show you this. So you can see the wires down here that are coming from the 2 modules. This one here is coming from the modules to the left, and this one here is coming from the modules to the right. Well, you'll notice we have red tape on 2 of them because these are the positive connections from the DC. Positive connection required by Article 210.5 on identification of the ungrounded conductor to be positive terminals. They must be marked in red or marked with the positive number, a positive sign, and with the word positive. All grounded conductors, all right, must be marked with a white wire. And although it would be also nice for them to be marked negative, the key with DC is the negative is usually always the grounded conductor. So that means that we should be marking all of our grounded conductors, all our negative terminals with white, so that we know that they are the negative ungrounded or grounded conductors that are going into our source. So we'll take this time here to do it properly so future classes can see that marking. And that means that on DC we're going to see red and white, and on AC we're going to see black and white.